Okay, so Grasshopper. So we all did last time. We kind of had we did some attractor point things where people had a point and then they had a circle that grew or something scaled or something, multiplied or something like that. So we're going to do another version of that and manifest it in a little bit different of a way, but it's still going to be attractor point based. And then I promise once we get our feet wet in it again, we'll start to do some really complex things that might drive people a little crazy when they try to figure them out. So for this, we're going to try to do as much of this inside of Grasshopper and the only thing we'll put inside of Rhino will be the actually, no, we don't have to do that. We won't even put that in there. We're going to do everything in Grasshopper. There's not going to be a single thing inside of Rhino. So first thing I'm going to do is build a point. Anybody remember how we build a point inside of Grasshopper? So we're going to create the point in Grasshopper, but we don't want it in Rhino. Nobody? All right. So there's a point node. So that's the point node, but you can see that there's no point, right? So then in the inside of that first bit.
Now you don't want to use like Rhino at all, because I know you can right-click it and set a point.
Sure, you could do that. You could do this. You could drop a point in here. Get right-click, set one point, select that, and then we have a point. But I want to do this without anything, if at all possible, inside of Rhino. Oh, we got multiple hands. Brandon.
Construct a point.
Construct a point. Love it. It's exactly what we got to do. So inside of the vector tool, which has the arrow, there is a point, tab. And inside of there, you can construct a point, right? And you can, I'm going to delete that, and you can put in numbers for the X, Y, and Z coordinate and build that point. So what would you put into these X, Y, and Z buttons?
Integer or a slider.
Integer or a slider, perfect. We're going to use sliders. Sliders are always, when in doubt, use a slider, so that way you can change it later. A quick way to create a slider, just so everybody knows, if you double click inside of, you also see that it does create a point automatically at 0, 0, 0. But we're gonna, we want to move that point around. So this is going to be the point that is the attractor. So a quick way to create a slider without searching for it is if you type in the start number that you want the slider to be, 2 periods, and then the end number. So let's say 100. You now create a slider that goes 0 to 100 without having to put the slider in, double click on it, and set the high and low points, right? So just so everybody sees that again, double click the start number, 2 periods, and then the end number, we'll make that one 500. And then you have a slider that goes 0 to 500 or 0 to whatever. So I'm going to plug those into here. And you'll see that now if I move these sliders, that point moves around, and that's our attractor point. I'm going to copy and paste one of those, and I'm going to do a Z1 as well. I'll put that at 0. All right, so here is our attractor. So another thing you might want to do, this is useful for when you are working in your scripts, which will probably get maybe large, is there's I don't know exactly where it is in the top bar, but there is a tool called Scribble. So if you just double click and you search Scribble, you can put a note in here. So you can say this is our attractor. So that we know what this is, right? So you can kind of track those things. And so make sure you kind of label these things as you make them, right? So I'm going to copy this. I'm going to create, so that is our attractor point. And then I'm going to make our start point. which we are going to replicate, right? So I'm just going to put that one all the way at 0. So this we'll call this one. I'm going to copy and paste this, bring this down, and call this the start point. Okay, everybody follow along so far? We just got 2 points constructed, not that complicated. So what we're going to do is make a bunch of these. We're going to array this point around. We're going to create our base of points, right, that we're going to kind of operate from. So how would we create multiple copies of this, array this out? Anybody have any ideas? Array. Perfect. You know, leading with the answer. So inside of the little squiggle here, the transform bar, because we are transforming something, we're taking something, we're moving it, we're scaling it, we're copying it, we're transforming it in some way. So inside the transform tab, there's a tab called array, and we are just going to use the rectangular array tool, which is that top one right there, the multiple points in the rectangle. Okay? So we have 4 things to plug into this. We have, is there any way to make this not so blurry? Because you guys can't really read that, can you? Maybe I'm just blind and I can't. Volume. I don't know if there's a way to adjust that.
It looks like it's just that side of the screen.
Oh, there we go. There you got it, Martin. There you go. Closer. That one. Stop there. Oh. You guys tell me. What do you guys think? Everybody see it or no? You feel better about it? Okay, anyway, so we have four items to go in there. We have geometry, we have cell, we have X and Y count. What do we think goes in the geometry? So we want to take this start point and we want to array it. So what do we think goes in the geometry plug? Trayvon. I saw you furrowed brow back there, so I'm giving you had a furrowed brow. Any idea? Take a guess. No wrong answers. Well, there's a wrong answer, but you know, this is a safe space. This is a safe space. You can be wrong here. It's all right. I guarantee you, somewhere in the script, I will screw something up. I promise. So, was that? Okay, slider. So we want to. There will be a slider that goes in here, but it won't go into the geometry. So we want the geometry is taking a piece of geometry, like what geometry, what thing, what line, what point, what shape do we want to array? So that's what it's asking. You can phone a friend to Alexis. The point, okay. So the point, so do you understand why that is, Trayvon? So what this array tool is asking is, it's asking 4 things. So it's what's called a rectangular array. So it's asking, what do you want to array? So that's the geometry question. So what do we want to array? And that is the point. So you see when I plug that in there, an array happens, right? Then it's saying, how do you want to array it? Like, what is the dimension that you want to array it? Because if I zoom in here, you'll see that there's this box here, this rectangle, and that is what the cell is. Okay, so if I hover over this cell, if you probably hard to read, but it says a rectangle with a width of 10 and a height of 5. So this green rectangle here is 5 tall and 10 wide, whatever dimensions, 5 inches, 10 inches, 5 feet, 10 feet, something like that. So what that is saying is I want you to take this point and I want you to basically make 3 other points at the corners of that rectangle, right, at that shape. So I want you to go, when you're moving this direction, I want you to go 5. All the points going this direction are 5. All the points going this direction are 10. Does that kind of make sense? And then it's asking X and Y, which means how many in the X direction do we want to go, and how many points do we want to go in the X direction, right? So you can see here, if I hover over this, you probably can't read that. I can barely read it. It says 6. So 1, 2, 3, 4, 5, 6. I'm moving 6 in the X direction. And if I hover over the Y, I'm moving 3 in the Y direction. 1, 2, 3. Right? Does that kind of make sense a little bit? So if I wanted to change how many this is, to your point about the slider, I would use a slider. Okay? So if I make a slider, again, I double click, 0, 2 periods, and I'm going to say 25, I'll do 50. I'm going to make 2 of those. And if I make these not 0, and I plug that into X, you'll see that I've now copied that out 23 times. All right, so I've moved out, and if I change the slider, and on this one, I'm changing the X. I'm changing how many X's I want to copy. And if I put in the Y, it's going to go in that direction. And I can adjust how many Y's I want to go. Y's and X's, right? So I'm just taking that one point and arraying it out over that many different spots. Does that make sense? And if you wanted to, another way to kind of track what you're doing is you can rename things, right? So I double clicked on that slider and I could say this is X count, so I don't forget. And now it'll say X count right there, so I remember what that's plugging into, because sometimes you'll have things plugging in across a big definition. So you may want to rename them sometimes. So I'm going to call this one Y count. It's always good to be organized in the beginning, so that way in the end you know where you're going. And if you really wanted to be super organized, you could come over here, copy another note, and say this is my array. Or I'll call it my base array. Okay? Everybody with me so far? Any questions? Okay. So now, what I want to do, the end goal here is to create an undulating, just so you guys know the end goal. The end goal is to create this undulating surface that is based off of the attractor point, so that the surface undulates based on where that point is. And I'm going to use points to do that. So this is my base level of points, right? So if I made a surface out of this, it would just be a flat surface. But I want to extrude, I want to move these up to a different height, right, based on the height of this point. There's a dozen ways to do that. What is somebody thought on how you might do that? What's one tool we might do to move these in the Z direction? Extrude, okay. Extrude would be, I don't actually know if you can extrude points. It's a good question. But I probably wouldn't err on the side of extrude. But if it was a rectangle or a circle or something like that, you could definitely extrude it.
You just mean to move that whole group of points?
Yeah. There's one way we could do it, which is a move command. So if I went into transform, where's the move? We're going to do it a little bit different of a way, but here's the move. So we'll Haley, since this is your idea, what do you think we plug into the geometry section of the move command?
Well, from the top of my head, I'm not sure this is right, but does distance have to be used for this too? Like distance between the extractor point and all the other points?
For sure, definitely does. So the way the move command works, it has two plugs. It has geometry and it has motion. So distance is going to go kind of in the motion plug. What do you think is going to go in the geometry plug?
Slider.
Hmm?
Slider. No.
So whenever it's asking for geometry, it's asking what do you want to move. So this was asking what do you want to array. This is asking what do you want to move.
So you want to move the array, right?
You want to move the points that are in the array, right? So you can see when you do the array, you have two plugs that come out. One is geometry, And if I hover over geometry, you'll see it's just a list of points. And if you hover over transform, you'll actually see that it's a series of moves. So this is like basically doing this move command on however many points. But it's just telling you these aren't, this is like how it's moving something. This isn't the actual point. The point is in the geometry. So you'll see if I plug in geometry to here, without even doing anything, I've now moved all of those points up. Because if I hover over motion, you can see it says translation vector, and it says 0, 0, 10. What does that mean? What does 0, 0, 10 mean? 10 units up in the Z direction, right? So it's X, always X, Y, Z. So it's automatically moving it up 10 units. So what will we put in here if we wanted to move it more than 10?
Put in a slider.
Put on a slider. Nothing happened.
Oh, don't you need, because the motion has X, Y, and Z, so.
There's a hint in this name right here. You can read that. So it's translation vector is what it says. Vector, already got it. So you have to plug a vector into that, right? So if I go over to the vector command and I go to, I want to move it in the Z direction. So here's a vector. The Z has a plug in it where you can have a factor of Z. So how many Z's do you want to move it? So if I plug that there and I plug this here, you'll see that they now are there and they can move up and down, right? So that's one way to do this. It's not necessarily the way. So that's one method, and you could very easily do the attractor point in that method. I'm going to show you. I'm going to do another method just because there's always a bunch of ways to do something. The one thing I forgot I wanted to do. I'm going to leave that alone, actually. I just do it like this. Okay, so what I'm going to do is I want to draw a line at every single one of these points that is going in the Z direction. Does anybody have a thought of how I might do that?
Remove one of the counts.
Was that?
Remove one of the counts.
Remove. So I want to remove one of the counts. So you want to. Sorry again?
Delete the X count.
So that'll only give me a Y count. So what I want to, so just confirm what I want to do. I want to basically have a line start at every point. I want to draw it up. So there's a bunch of different ways to draw lines. So in the curve tool, there is, if I go on to the third tab, the third table over, or the third, whatever you want to call it. Oh, CC Cleaner, half price, don't miss it. There's a few different ways at the very top to draw a line. You can have a fit line, which is, you could have a line, you can have a bunch of different points and it will draw the line of best fit across those points. You could just draw a line between 2 points. So you have point A, point B, draw a line from those 2 points. Create a line between 2 planes, create a line from 4 points, create a line by segment defined by a start point, tangent, and length. Tangent lines, all these different things. Which one of these do we think we should use? Do you have any ideas?
What is SDL?
SDL.
What is that?
So that's the line SDL. It is create a line segment defined by a start point, tangent, and length. When it says tangent, it kind of means the direction.
What would be that one then, right?
It would be that one. So what do we plug into the start?
Which is all those, which is that. So the geometry? Yeah, you plug that.
Geometry. So I plug that into the start, and now if you look here, you have a bunch of little lines, little mini lines at every single point. Because if I hover over direction, it says 0, 0, 1, which means it's going in the Z direction. And if I hover over the length, it says 1, so it's going 1 unit up. All right? So, bam, I got all my lines. But I want these lines, the length of these lines to be based off of where that attractor point is. So how would we go about getting, basically, like, I want to know how far is this attractor point from this point, and how, whatever that distance is, I want that line to be that long. And same across all of them. So what would we need to do to get that? You have any ideas?
Well, first you need to plug in the direction you want, and then you can. The length is being dictated by the attractor point, right?
The length is dictated by the attractor point, yeah.
So
We can plug in a direction. It just so happens that the direction is already going the way we want. So you could put Z vector in there, and it wouldn't change anything, but it'd be a little bit. So if I wanted it to go in the X direction, then I have to put in a vector in there so it goes the right direction.
So then you plug in the attractor.
Where would I plug that in?
Well, no, I was gonna say you'd plug the attractor point into the length, but that's not giving it an output. It's just plugging the point into the length.
Yeah. So if I plug that into here, it does something.
But it's not what you want.
But it's not what I want. And what it really is probably doing, I think, is it's probably taking that first number, 43, and just translating it in.
Right.
So if I went back to X, you'll see that it's changing that height. So just taking that first number, which isn't really what we want. But it does technically work, but it's just not getting us the result we want.
Do you need like a list?
A list of what?
It's
A list of numbers. A list of numbers.
X, Y, and Z, or of X, a list of X values. I'm not giving my answer.
So you have to plug in like the factor, or I remember doing something with the math.
Okay.
And
So just to define what we want to know what is the distance from here to here. So we want to find the what?
distance.
The distance, and there just so happens to be a node called distance. So, which in a way is X values. It's the distance, but it's mostly, if you imagine a straight line drawn, which right now would be an X value because it's kind of flat, XY value, I guess. But if it had height to it, it wouldn't be an X value. So let me just find, I just don't know where it is naturally. I thought it was in intersect transform.
I think I counted in vector.
It's in vector, yeah, there we go. So in vector point, as Martin so aptly found, in vector point, in that second bit, there's a thing called distance. And it basically is saying, what's point A, what's point B, and I'm going to tell you the distance. So what should I plug into point A and point B? So I want to know the distance between that point and every single one of these points in a list, as Isaac so aptly put.
Point A should be the reference point, and then point B should be the array.
Point A is the reference. Point B is the array, which is this geometry point. And you'll see if I put in a panel, which just shows us what's coming out of this. Plug this into here. Similar to what Isaac suggested, we want a list of numbers. And there's your list of numbers. And you'll see that there's, 293 numbers. And if I hover over this geometry, I bet you we have 209, well, it's a list that goes to 293, but it starts at 0, because all lists in Grasshopper start at 0. So there's actually 294 numbers in this list, and there happens to be 294 points in that array. So it is telling me between the first point and the attractor point, it's 103 point something 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 units between that point and probably the point over here. And then the next point, it's this far, and this point, this far, and this far. So now we got this list, Isaac, what are we plugging into?
The length.
The length. Ta-da! And now we have all of these lines. I'm going to shrink this down a little bit so it's not so intense right now, so we can kind of see it a little more easily. So you'll see that I have a bunch of lines, all different lengths. And then if I come back to this attractor point, and I move the attractor point around, you'll see that I get these lines all change. Right? We all following along, we all understand how this is happening. We have our inputs, which is our point, and our distance, and we're processing that by making that point an array, and then making a line out of that array diffusing the length. So we understand that so far. Cool. All right. So I will base array. I'm going to, I'll try to be organized, and I will call this area over here my my line height. Okay. So now what we want to do is we want to find the endpoint of all of these lines. This is a little, like I said, the other way that Haley was suggesting was probably a little bit easier of a way to do it, but we want to use more tools. We want to get used to using other things. And stuff like this is going to become useful in the next few lectures on how to draw these lines and do things. So just know that Haley was right in his thoughts before, that this is all you were trying to do, that's how you would do it. But we're trying to use more tools here. So how do we get the endpoints of those lines? Stored in a data box.
I remember, I'm not sure. I remember like the notebook on the side show like the coordinates. There's not points on top. It's right there.
Yeah, so if I just put a panel here just to see what's coming out, what you'll see is this is basically saying it's a line and it's this long. It's a line and it's this long. It's a line and it's this long. But it's not really a point. It's just kind of defining that they're lines and they have a length to them. It doesn't really tell you what direction it's going. It doesn't tell you where it starts and stops. It just says it's a line. So what we're looking for is the end point. Similar to distance, there happens to be a node that's called endpoints. So if I type in endpoints, I'll try to find it. It's probably in analysis. Maybe it's in curve. Yeah, so in curve, because we have curves, these are lines. We want to find the endpoints of those curves. So in curve, in the first bit, in the analysis section, there is a node called endpoints, which is here. So what do we plug into curve?
The line.
Line. Lines and curves are pretty synonymous most of the time. So if I do that, you'll now see that I have little x's or little points at the end of all the lines, and I actually have a second point at the bottom because it's showing me both the start and the end. So which one of those points do we want? The end point. Perfect. So what we want to do actually is we want to make a surface out of those points. So I want a surface that basically follows all of those endpoints and creates a curved surface on top of that. Inside of the surface command is a tool in free form. It's called surface from points. Pretty easy. So I'm going to click on that. I'm going to drop that in. And now this has 3 different plugs. So first is points. What do we think we plug into points? End. I'm going to plug the endpoint into there. And then we don't actually need to do anything with interpolate. If I'm being honest with myself, I don't fully know interpolate samples. I'm not sure what interpolate actually does. But we do need the number of points in the U direction, which is basically, we talked about UV values before. Do you remember what UV stands for? We talked about it sort of in the frame of, you probably heard it in terms of UV maps for materials, but we talked about it a little bit before about surfaces. Do we remember what UV, U and V stand for? Nope. Remember, we know what X and Y is, right?
Oh, you and their reference points, right? On so like a surface that you're trying to reference.
Sure.
The U and the V, aren't they almost like the X and the Y, but on that specific surface that you're trying to reference? Yeah. So they are based on a surface, right? So you could have a flat surface, and what it said, what your UV map is it says, if I came over here into, I'm just going to draw a quick surface here. So you have X, Y. So this plane here. Let me make this a little bigger so we can. Let me hide this for a second. So here we go. We have our X direction here and our Y direction here, and then we have our surface. If I wanted to know exactly where the corner of this surface was, one way to know that is to know the exact X, Y, and Z point that it falls on. So I could say that, I don't know what it is, but X is 10, Y is 10, and Z is 0, and that happens to land exactly on that corner. But sometimes that's not very useful in the Grasshopper world. Sometimes I don't care about the rest of these points. I don't care about X, 0, 0, X, Y, 0, 0, or -1 and positive 10 or whatever. I only care about the points that fall on this surface. So there's a different term for those points in there called the UV points. So it's based on a particular surface. So every surface has its own UV. So I could have 2 of these surfaces. So I could have 2 surfaces here. They're the same surface, but they're in different locations. So this X, Y, Z of this point is different than this X, Y, and Z of this point. But the UV of both of these surfaces can be the same. So U and V, so X, Y just goes infinity to infinity as far as you want. UV only goes from 0 to 1. So 0, 0, so a U value of 0 and a V value of 0 would be this first point on the surface. Literally somewhere on the surface, not always this exact corner, but likely this surface, that would be 0, 0, 0, 0. And 1, 1 would be the opposite. And everything in between is like 0.1, 0.11, and point something something, and it goes just from 0 to 1. And 0, 0 on this surface is that point, and this has a 0, 0 as well, but it's different because it's based on a specific surface, right? This will become very important, at least having that base understanding as you develop a project. But and any surface, so this happens to be flat. If it was curved, it doesn't matter. It could be all kinds of crazy curves. A UV is always going to land on the surface, and you can find, it's going to be somewhere between 0 and 1. And the benefit of that is that you can find a point on this surface, and then once you have that point with the UV, you can use Grasshopper to figure out where is that point in the XYZ plane. You could kind of translate it back to kind of understand that. So if you wanted a line to always be right at a specific point on the surface, you could find that using UV, translate it back to get the actual XYZ point, and then start a line based on that point. Now it's a little bit convoluted, but it's important to know that you can kind of translate them back and forth. Does everybody have a baby understanding of UV? Do we know we understand what it is? Very small understanding. The things you remember is UV will relate to a specific surface. You pick that surface, and that surface has its own UV. And all it does is represent a point on that surface. It'll become a little bit more obvious, hopefully, as we do it over and over and over again. So I'm going to delete those out. So anyway, back to Grasshopper. So we got this. So the U count is just telling it how much in the U direction are we going. And I believe what it's looking for, let me check though, I don't always get this right. I believe we plug in, yes, that's not right. There we go. So it's looking for one of these counts, right? So one of these, X or Y, is running in the same direction as U. I didn't know which one it was, so I plugged in both. And you'll see when I plug in the X to the U count, it gets this crazy looking thing, which is not what we want. What we want is the Y. So if I plug in the Y, you'll see that I now have a surface that follows all of those points, right? So now that I have this surface, you'll see if I go back here and I change some of these things, I add to the array this direction, I move the attractor point, you'll see that the surface shifts, moves up and down. I can even move the start point of the whole array, and everything shifts. So it's always tracking live. How far is that point from the other points? So you can see it's always changing. Right, so this is one of the benefits of, and if I wanted to, if I wanted to kind of keep a version of this surface, what do we do to get this surface back into Rhino? Bake. I love it. You guys watch, what is it? What's that show? Great British Baking Show? Where they bake? We're going to bake, so we can bake it in. You pick the layer, put it in, now we have a surface here, and then we can change it. We can say, I want a little bit more surface this direction. I can bake it again if I wanted to. Bake. And then I could get different, oops, I baked the points instead, oopsies. Bake, there we go. Now we got a different surface, and you can kind of do multiple ones and do different versions of it, so on and so forth. Does everybody understand that so far? We understand what we did. We took the points, we're tracking its location, we're moving the points based on the distance. We're then using those points to create a surface out of them, and kind of do we understand the process in which we just undertook? Okay, so the next thing we want to do, so just an FYI, we have all this kind of messiness in here, and you're like, I don't want to see all these points, I don't want to see all these lines. If you select over everything, so you can come over here, you can add some, what I kind of like to do sometimes in my script is, like, whenever I do have something like the area that I want to bake in, I'll label that area, this is the bake
So that way, whenever I change something and I want to be like, where's that node that I got to click on and bake? Sometimes you got to bake multiple nodes. I might put them all in an area and say, these are the ones you have to bake in. But anyway, so sometimes you may not want to see all this nonsense. So we can select everything that we don't want to see. We can middle click with our middle mouse, and then we have a little blindfold over here, which is disable the preview. And then I can only see just that surface, right? Everything's still attached, everything still works. It's just you only see the surface now rather than everything. Okay, so now the real fun part. So last time, I hope we're gonna get into another concept that we're gonna have to try to wrap our minds around here. So last time when you guys were making these kind of attractor point things, you ran into some situations where, oh, the heights were so high. Like this is kind of a drastic shape. You know, maybe this isn't, I don't want it to be this drastic. I know we're talking about distances between lines, so you could just change the distances between the line. You can move the attractor point so it's not so drastic. But let's say you were working with other information. Let's say you were tracking wind speed at your site, and sometimes the wind gets too high. And so let's say you had a facade and you wanted it to open up when the wind gets a certain, running a certain speed. The wind can be drastic. You can have 50-mile-an-hour winds, or you can have no wind at all. But maybe the facade can only open so far. And if it was plugging in 50, it would break because the facade it would have like a max, right? And you want it to hit the max only at a certain speed. So you need to kind of reevaluate how this, when those numbers come in, how they're processed, right? So you want to kind of reassign them. Last time we did just like regular math equations. I said, oh, just divide it by a number, like use a division tool. Remember that? There's actually a little bit easier and better way to do that, but it's just a little bit more complicated to understand. But this will be important, I think, be used by everybody. So what we can do is called remap the numbers, okay? Which is basically say, hey, I have a bunch of numbers. Panel, see those numbers. Well, actually, just now that we've done it, where are we getting the number of how high this line gets extruded? Where is that number in this definition? Do you remember? So like how are we getting that point to here and this point to here and that point back there to here? End point?
Yeah. Isn't it?
So this is telling us where the points are, but it's not telling us the height. I just want to get the height.
Just a line. Or, yeah, a line.
So the line does have height in it.
Distance.
Distance. There we go. So the distance will just pop out. So if to your point, Isaac, if you see that first number 58.9, I plug in the first line, you'll see that the first number here is 58.9. But this is a line, right? So I'd have to like process this again to get that 58.9 out. So if I want to just get the 58.9, I can get that from the distance. So let's say you didn't want it to be so high. Like if I drug this down, see we have some pretty drastic numbers in here. We have some 80s, 70s, 81. I don't know what the highest number is in here, but it's probably, looks like it's 80 or 90 or something like that. Up some hundreds. So yeah, we have 131 down here. But let's say we didn't want it to be 131. Let's say that's way too big for this thing. Let's say I only wanted it to be, the maximum number I wanted it to be was 20. And the minimum number I wanted it to be was 5. But I wanted the relationship between all these numbers to remain the same, right? So it's like I wanted 130, or whatever it is, 131, to be the 20, and whatever the minimal number is in here, I don't know where it is, let's say it's 50, I wanted that to be the 5. But I wanted between those two, I wanted all of them to have the same relationship. What we can do is remap those numbers. We can basically take all these numbers, get their relationship, and remap them in a list that it goes from 5 to 20, and it keeps that same relationship, right? So I'll show us how to do that, which will introduce us to some other tools and concepts. So similar to the distance and the endpoints, there is a tool called remap numbers, right? I think it is in transform. No, it's in math. Maths. Yeah, right here. In maths, the first tab is called domain, and there's a remap numbers tool. And it's asking for 3 things. It's asking for the value. It's basically asking, what do you want to remap? Then it's asking for the source. So what is the domain of that source? And what is the target domain? Does anybody know what domain means? It's okay if you don't, but I'm sure it has actual mathematical principle side to it, but I only know what it means in Grasshopper.
So like the parameters?
The parameters.
Can operate
So what, can you define that a little further?
it'll work between this and that.
100% what it is. So it'll say, what is your source domain? So it wants to know in this list, what is the domain of those numbers? From where do they start and where do they end? What's the lowest and what's the highest? And then it's asking you what your target domain is, meaning how do you want to reevaluate those numbers, and what's the new lowest and the new highest?
What is that command that you put in?
It's called remap numbers. So in the second tab up here in maths, because we're British, there's a domain. The first table is called domain, and then down there is 6 or 7 down is called remap numbers. Did everybody understand that? Basic, it's just like from what to what. So what do we think? So the value is what we want to remap, what numbers we want to reevaluate. So I want to change all these distances. So what do you think we should plug into the value? Distances. So I'm going to plug the distances in here. I'm going to keep this here just for posterity so we can see how it changes.
Can you also plug it from the panel to that?
I could, yeah. I can 100% just plug. The panel is just a pass-through, just showing us what's in there, so you could do that too. No different. So then we want the source domain. So we want to know what the minimum and maximum numbers are in this list. And if you go into domain, you'll see that there is a tool, third from the top, called bounds. And you'll see it has a little min and a little max. So if I click on bounds, it's saying, okay, I want to get the domain, but it's asking you to plug in the numbers that you want the domain of. So what do you think we plug into there? Oh? No. So we want to know the domain of the numbers of these distances, basically these numbers. So we want to know what the lowest number is and what the highest number is. So we're going to plug these numbers into there. So I'm going to plug those in like that, and you'll see if I put in another panel, you'll see that it has something that says 31.4 blah 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 to 131.2129707, which is basically saying the lowest number in that list is 31, highest number in that list is 131. So you would plug those. Where do you think we plug those? So now that we have that source, so that's our source value. And what you'll see here, you see how this is gray? Before, if I unplug this, it's orange. Anytime something is orange means that it still needs more information. If it's red, that means it has bad information. If it's gray, that means it technically doesn't need any more information. But if I plug a panel in on the other side, here, you'll see this is the same list of numbers, technically. If I go to the top,
it has changed 58 to 0.27.
Because if I hover over this target, you'll see that it says
The locally defined value of
0 to 1. So it's basically taken all those numbers and remapped them from 0 to 1. So the number that is the lowest is now 0, and the number that is the highest, which is at the bottom, is the number 1. Does that make sense? Roughly? What's up?
Is that like scaled with the numbers, or is it just like, or how do you get the numbers?
It's basically, yeah, it's a good way to think about it.
It's kind of scaling the numbers, right? So it's taking
All the numbers, and it's saying
whatever the highest value is, I'm going to make it 1. Whatever the lowest value is, I'm going to make it 0. I'm going to keep the relationship between all of them. So the second number, I'm basically going to divide however many numbers there are by from 0 to 1. And I'm going to change all of them so that their relationships stay the same. So like, let's say you had a list of numbers. See if I can think of a way to show this. Let me see. What do I want to do? I'm just going to create a quick set of numbers. So I just created a series of numbers from 1 to 10. So this is just a series. This isn't very important, but this is just a way to create a series of numbers. I picked a start, which is 0. I picked a step, like how many numbers is it going to step? It's going to step 1 number every step, and it's going to take 10 steps. So if you'll see over here, I now have a panel that has 0. It should have 0 to 9. If I change the step to 2, you'll see, or to 2, you'll see it's now 2, 4, 6, 8. You know, it's just a way to create a quick series. So it's just, I made it 0, get 1. So just a quick series of numbers, so it goes from 0 to 9. Let me actually make it from 0 to 10, or so it actually goes to 10. There. I'm going to remap these. Let me copy this. Just trying to show an example, a little easier to understand example. So here's the value. Here's the source. So you'll see now, so I have just regular numbers from 0 to 10.
So the lowest number in that list is 0. The highest number in that list is 10.
I'm remapping it if I hover over this target from 0 to 1. So you now see that the 0 is still 0. That's the lowest number.
The highest number, 10, is now a 1. The middle number, 5, so these relate, you know, zeros relate, ones relate. The middle number is now 0.5, right? So it's just remap, it's just keeping the same relationship between the numbers, it's just changing them.
Does that kind of does that make sense? See some shaking yeses, but maybe they're just appealing. So now let me show you how this is useful for this. So I said, what did I say? I said I wanted them to go from 5 to 20, right? I don't want 0 to 1. That's not going to be, these are going to be tiny little lines. We don't want them to be, 6 inches tall. So I need to create a domain, or one might say construct a domain, because that is the tool we will use. So if I go back to maths and I go to that first tab of domains, you'll see at the very top there are two things. There's construct domain, deconstruct domain. Just like there's a construct a point and a deconstruct a point. If you have a point and you want to know its information, you deconstruct it. If you want to create a point, you construct it. So I'm going to construct a domain. And it's asking me, where do you want to start and where do you want to stop? So if I want to go from, if I want the minimum to be the minimum value of these lines, the height here to be 5, and the maximum to be 20, what do you think I should put into the start of this domain and the end of this domain? What is it? 5 and 20. So I'm going to put a 5 into the start. Change my slider to go to 20. A 20 into the end. And you'll now see if I plug a panel into here, you'll say from 5 to 20. So it's going to remap these numbers. If I plug this target in here, it's going to remap them and make the lowest value 5 and the highest value 20. Plug that in. You'll see that this bottom number was the highest number, so that is now 20. And if I scrolled through these 300 numbers, I'm sure I'd find the minimum somewhere. Right there. There's two numbers, two values are the lowest. They have the same number, so those are both 5. And there may be other 5s in there too. So now I have a new list of numbers. The relationship's exactly the same, but it's changed. It just made it a little smaller, so it's not so drastic. So what do I do if I want this to if I want to use these numbers now? Where do I plug these new numbers into? Any idea? What's that? Into what?
Into the length.
Into the length. So I'm going to take these map numbers, I'm going to plug them into the length, and then whoop, much more subtle of a curve now. Everything's the same. If I change the attractor point, it'll shift, but it's not shifting so drastically. It's a lot more subtle. If I don't think that's too much, if I don't think that's enough, I could change the minimum down. I could change the maximum. I can make this, 200. I can change the maximum again, and I could give it, if I, play with it a little bit to get the height that I want. Does that kind of make sense, everybody? So what would I do if I wanted to completely reverse this? So I didn't want I wanted to, right now it's the furthest point. If I turn, this back on, I see that point. I want to see this. I don't want to see that. No, I do want to see that. So I have my my attractor point down there. So whatever point is the furthest away from that point, which is one of these, this one over here, these corners, is the highest. What if I wanted to do the opposite? What if I wanted that to be the lowest, and then the point that's closest to be the highest? Anybody know what we might want to do to make that happen? Reverse node? There's a reverse list. You could reverse a list. So if you had a list of numbers and you just wanted to reverse it and take the one number that was at the bottom and put it at the top, you could do that. But it's not really going to work for us. So all I want to do is reorganize the numbers basically and say, well, whatever the highest number is, I want it to be on the lowest end, and the lowest number to be on the highest end. So all I need to do to reverse everything is just flip these two numbers for this domain. So right now it's saying the start is 1 and the end is 24. But if I make the start 24 and the end 1, it'll flip everything back upside down, right? So if I look at this, I plug this here and this here, now it's upside down. This is basically saying, okay, whatever the highest number is, now make it the lowest. Whatever the lowest number is, make it the highest. Put them back around. I don't like it that way. I can do it that way. If I just plug the same number into both, it's just flat. Because you're remapping all the numbers to be 1 now, instead of, or whatever number I put in here. So I'm just moving a plane up and down. Do we understand that at all? Do we feel... So now if I move this point around, my attractor point, you'll see that the high end is just shifting around. I can kind of flatten it out a little bit by raising the point higher, so it's a little bit more uniform. If I wanted this to touch the ground, if I wanted points to touch the ground potentially, I could change the start to 0. So you see that one's touching the ground there. That's the furthest away. I have to find the right point for these all to touch the ground, but do we understand? Was everybody able to follow along, understand how that sort of works? The domain. We have questions. We're like, I'm a domain champion now. Haley.
Sorry, I was distracted. So how do you reverse the diversity?
So the point of the domain is to just create a start and an end. The start could be, it doesn't matter where the start and end are, the start could be higher or lower than the end, and vice versa. So if I wanted, what we did originally is we put the lowest number into the start and the highest number into the end, meaning that whatever the lowest number is in this list of distances up here, whatever the lowest number is going to become 0, whatever the highest number is going to become 24. If I flip that around, it does the inverse, where it says whatever the lowest number is, I want it to be 24, and whatever the highest number is, I want it to be 0. So this is an easy way, when you're tracking data, let's say, I don't know, pick any data point out there. I think of something weird. How many tweets there are about puppies every minute. Sometimes there might be no tweets about it. There's probably always a tweet about a puppy. But maybe there's only 10 or 15 tweets. But let's say a puppy gets rescued from a well in Philadelphia and everybody's tweeting about it. It could go to 1 million tweets about puppies all of a sudden, right? Hashtag puppies is trending on Twitter. I say this because you can bring information like that. Twitter, there's all kinds of stuff you can pull into Grasshopper. So that it's not completely out of the realm of possibility you don't have a puppy rescue center and you're basing your design off of how many times people are tweeting about puppies. But let's say your piece of architecture opens and closes. The more puppies they're talked about, the more it opens, and the less puppies are talked about, it closes. So the least amount you could talk about is 0, so it's completely closed. But the high-end number is unknowable. It could be a trillion tweet. I don't know how many people are on Twitter, probably billions. And every one of those people could tweet about puppies in a second. And then your architecture explodes because it tried to open or something too far. So you can set these mins and maxes so that when these numbers come in, it's kind of but maybe you don't ever want it to be closed fully, right? I don't want puppies to be completely covered. So you could say, well, when it's 0 tweets about puppies, I still want it to be opened at 5%. But if it's 1 billion tweets about puppies, I only want it to be open at 100% or whatever dimension, not 1 trillion% or however many about puppies, right? So, you could remap all kinds of data. It's just numbers, and you're just reevaluating numbers. You could talking about, trying to think of. So if you were thinking about it as a sunshade, as an example, in the winter we have a lower angle sun, so it's less harsh sun on a building, and in the summer you have a harder angle of sun. But let's say you always wanted your building to be most open when it was getting the maximum number of lumens or max number of radiance from the sun, so it's fully open. But in the winter, it would never hit that number, or in the summer, it would go way above that number. You can kind of remap all those numbers. So every day, it opens at its fullest and closes at its least. So it's just a way to kind of reevaluate numbers. Before we were doing just math, dividing it by a number just to get it kind of lower or higher. But this is a way to do that a little bit more controlled. So you're not kind of guessing and checking. You can kind of pick your minimums and your maximums. Domains will probably become useful in your projects, I almost promise you. There's an easy way to kind of to do these quick moves. But you can imagine this this is some sort of canopy, right? And this is the first shape that you're creating of your canopy. You know, like this is just the shape, but now you're going to panelize this in some way and create something off of it. Or you're going to create structure off of this, and we can start to do those things, right? You could even say, let's just see if we can do something quick, just for fun. I want to see if I can get the edges of those curves. What do I want? B-rep edges. So you see, I just got this thing here, which is called B-rep edges. You can follow along if you want, or just watch. I'm just trying to show how you might start to manipulate something else after this. Let me hide all this stuff beyond this point, so we only see the surface. So you'll see that you'll see that now with this B-rep, I can get the outside edges of the curve here. So if I click on this, you'll see that I highlighted in green here this outside edge. And let's say I wanted that to be some sort of like pipe. You know, I'm just trying to do something quick. I have a pipe command. I could say I want that to be a pipe. I want the radius to be between 0 and 5. So you see now I have a pipe around that edge. I can change that radius, but it'll change with me as my attractor point changes, you know, so that pipe always stays with it no matter what it's doing. It's kind of following along. I could get the endpoints of all those curves. So now I have those endpoints. I could, you know, if I wanted to have some sort of, let's call it a column of some sort. So I'm going to use that line command again, the line SDL. So I will get the start point. I'm going to get, they'll be the same. So I can get that. I can say my direction is a vector of z. Vector unit z. So this is something you can do if I put it, it's already going in the z direction, but I actually want it to go in the negative z direction. So something you can do, I'm just kind of running through some quick stuff here. You can add in expressions. So if on all of these little nodes here, if you right click on them, you can say I want to add an expression. So if I write in here x asterisk -1, what I'm saying, oh, not x, oh, yeah, that's fine. I think it has to be lowercase, actually. What I'm saying is anything that comes into this node, I want you to multiply it by -1. I want it to go the opposite direction. So then if I plug in the vector here, and then I put in a slider, now my lines are going down, right? So I can, instead, if I didn't have that expression in here, I delete that out and commit changes. It go up, right? So I can, if I put that expression in, I don't want it to go up. I want it to go down. That's a quick way you can make sure that it's always going down. You could also put in -1 into this factor as another way to do it. But then we wouldn't learn about this cool tool expressions. So then I have lines there. Now let's say those are my columns. I could do another pipe. I'm just using pipes as an example. Curves. Now I have something going down. So now I'm starting to create a piece, you know, a very simple, but a piece of architecture in some way, right? Some other things we can do. Let's say I wanted to have like kind of ribs going along this. So this is something, we'll get a little bit more into this. Let's say I wanted to have ribs going across. That would be lines on. Best way to do that.
Trying to think of a way to do it quickly.
What we got in here again? Just trying to think of a way to evaluate this. Let me get the endpoints of these lines. So I get the endpoints of those lines that come down, which will give me the bottom point. Panel. I want the start, I want the end. So something that we'll get into a little bit. So I have a list of points here. So I just took the line that I extruded down here, and I got the endpoints out of it. So I took that line, I got the curve, and here's the end. I just put a point node right here to see them. So if I click on this node right here, you'll see that I got all these little points. But there's 4 of them. Right now, 1, 2, 3, 4. 0 to 3. But what I want to do, what I was imagining doing, I wanted to get a curve that followed this surface. So I was trying to imagine how I might do that. And the one thing I thought was, I'll draw lines and I'll extrude a plane up and I'll get the intersection of that curve, which is something you can evaluate. So I was like, there's probably other ways to do it. This is just the first way I thought. I was like, I'll get these endpoints. I'll find 2 of them. I'll draw a line across to connect and get points, and then draw lines that way and extrude up. Yep. No, go ahead.
With the change of direction, what's the vector? Like, which vector do you use to change the direction?
So, what I did here.
Yeah.
So the direction is Z, but I want it to go down.
Yeah.
So what I did was on direction, right click. You right click on this. See how there's this little asterisk here? If I right click on direction, there is a click called expression. And if you click on that, it'll give you a little box, a little header, and you can basically write a little equation, right? So when you write these equations, if you write x represents whatever's being plugged in to that node. So I said I want x. I wish I could make this larger. I just wrote x asterisk, which is representative of multiplication. So it's x asterisk -1. So that way it says x is whatever's plugged in. So whatever is plugged in, multiply that by -1, which in this case is a vector. So a negative vector is going downward, is going in the negative direction. Not happening? We got all kinds of errors. You have a unit vector, so you don't have, so you need the z. So you're going to want to go to the vector tab, or you can put the letter z there. Go to vector, which is the last unit z. And now I plug that in. Now it's not working. So it's working now. Cool. Mm-hmm. Anybody else struggling with that or understanding what that means? I went a little fast through it, just trying to pop something out at the end that looked like it was a piece of architecture. So let's see if I can't quickly achieve what I was doing. So so back here, I got my points here. I got my endpoints of this curve, which are that. But I don't want all of them. I want to separate them maybe. So I want to get each one individually.
So this is something we'll get into a little deeper, but we need to give each point separated out into its own node. But this is a list, right? So what you can, these are items, quote unquote, items in a list. So there is a tool called list item. And we'll get into this, I promise, as we go here. So I can plug into here, and what I can do is when I hover in here, I get these pluses. If I hover in and I put that number there, I add numbers to here. I think I need 4 of them. I should now have one of those points. So see, I basically took the list, I plugged it in, I added 4 nodes, 4 of these. I only have 4 items in this list, so now each of these points, so you can see that one is that node. If I copy this 4 times, I plug that one there, this one here, I have them all separated as different points, right? So now I can draw lines if I wanted to between them. I'm going real quick, so if you can't follow along, completely understand. So that's a good one. So I want to draw a line between those 2 points like that. I want to draw a line between these 2 points like that. So now I have lines like that, like those 2 lines going there. I can divide those, divide a curve. You know, I can divide them by the same number, say 10. That way they have the same number of points. So you can see I'm just dividing those lines into equal distant space. And then I can, if I really want, and then what I was trying to do was create a line now between all of these. Whoop, that's the wrong way. So they're actually backwards, so I have to reverse one of these lists, and like we were talking before, we can reverse lists. So if I reverse it now that they are in the right direction, I can do that just by right-clicking on this node, and there's a reverse command. So what it was doing before, quickly, was it was relating this point to this point, but I don't want that. I want this point to that one and this one to that one. So I just reversed one of those lists, so that way it went the direction I wanted it to. We can use the extrude command to extrude these up. I'm just trying to get an intersection of the so I'm just going to extrude these up and so that they intersect the plane, and then I can get a, just trying to show you guys how these things start to come together into architecture, or potentially architecture. Intersect, I want to get the intersection between probably B rep to B rep. So I want this to be 1. And then where's my surface at? I'm not being very clean here, so. Okay, so now you'll see if I hide this, I now have lines that are the intersections of those surfaces coming up through. And if I want to just keep going with the pipe concept, I could go pipes, and I can draw a pipe along those surfaces. And now I'm starting to get a piece of architecture. You can imagine me doing that in the other direction, getting some sort of panelization or some sort of structural element. You could also do a sweep, right? You could say, these are my lines of my sweep. And the benefit of all this, there's still nothing in Rhino, right? Everything, if I was to close this right now, everything would disappear. So everything is still tied together. So if I adjust this attractor point, everything shifts. You know, it's starting to get a little slower because I'm doing a lot more stuff. Hopefully it doesn't crash. I could still change my domain. You know, I want it to be a little taller. So you can see I just changed my domain, but now my intersection isn't intersecting there anymore, right? So you can see how my pipes are starting to break. So everything's still tied together, and I could bake, you know, I would have to pull out the things, like I said, I would probably pull out a few things that I wanted, like I want to bake this, I want to bake, if I want to bake that, I want to bake this, I want to bake this. So if I right click on those and I bake and I pick a layer, like so. Oop. I didn't get everything. Bake, I can put them on different layers. Bake, bake, bake. So now you'll see inside of here, I now have the surface. You know, I made a quick piece of architecture relatively quickly, right? And this is all set. This is now disconnected because I baked it, but I could go back and change it and do a bunch of different stuff to it. So this is how, like, you know, the attractor point thing might seem like, it's a tracker point, I've done it 1,000 times, but you can see how it starts to kind of create something that you can then use as a piece of architecture. Like I said, the attractor point is more of an understanding that these are numbers. We're just getting numbers. So we're just getting a distance from one thing to the other. But I could also be getting the radiance of the sun. I could also be getting the wind speed on a given day and time. I could be getting the number of times we tweet about puppies. They're all just, you know, manipulating information and creating something, right? So we have really the input is the attractor point. The process is getting the distance of that attractor point, and the output is this weird little canopy that we made quickly. So it kind of relates back to the end goal of the project. Your projects will hopefully be a little bit more interesting than this weird little canopy, but this is a. I assume by the end of your projects you'll have much more nodes than this, or multiple definitions that are all working together that you all create that kind of create a piece of architecture. Haley. Yeah, the last bit was just me kind of like relating it to a piece of architecture. Like we just had a surface, so I wanted to make something out of it that was more interesting than a surface. But yes, I did report it, so I'll send it to everybody for you to look at. And I could even send you this. I don't want to send you the definition. You can create it. You'll have to create it yourself if you want to mess with it. That's how you learn anyway. Any questions or comments?
I have a slightly unrelated question.
Okay.
Was it neat to graph something? Like when you right click on a node, it says like graph? Because I've seen it in a few tutorials, but I don't know what that means at all.
Graph is a complicated concept that I don't even fully have in a grasp on. So when you right click on these, there's a few different options. Reverse, which we touched on, which just reverses the list. Flatten, which means when you have multiple lists, so you have, you know, many things in multiple lists, flatten basically takes everything and puts it in a single list, which makes it useful. Simplify, expression went over, which is kind of like you add an expression as something comes in. Simplify and graph is another one called, it's not in here, it's called reparameterize. I don't have a good explanation of graph or simp. I will see if I can come up with a better explanation. None of the definitions that I've created required it that I'm aware of. So let me do a little bit more research into that and see if I can come up with a better explanation. In the end, I know I'm like wicked smart, but I don't know everything. So good question. I'll see if I can get a better answer for you. Any other question? Are you pumped? Are you stoked to be back? You guys miss me? You miss me. I know you did. I don't care what you say, you miss me. All right, so assignment for, I'm going to stop recording this.